Hello, my name is Bradley Hanstead, Team Captain of Team Think Tank, and this is our official Battlebots 2016 application video. And now for a bit of the history of Team Think Tank. Team Think Tank formed when Ted Shimoda met Rick Blom at a hardware store. When they realized they had a common interest in building a combat robot, they built several for Battlebot. Throughout the years, Team Think Tank has had several members, some of which have gone on to start their own teams.
And in the blue square, introducing Ringmaster.
While Ringmaster was a highlight for Team Think Tank at Battlebots, we didn't stop there. Ted continued to innovate in combat robotics, and eventually used the 1-pound scale to create the robot that Team Think Tank is most famous for, VDD, Vertical Disc of Destruction. By altering form to improve function, Ted was able to create a rock-solid robot, and eventually would scale this up into larger weight classes. Now any combat robot builder would know what you mean if you described a robot as a VD. Team Think Tank's history was already vast, but this is where I come in. I'm 26 years old now, but I first got into combat robotics when I saw BattleBots on TV. I went to a local hobby store, but I pretty much just ended up getting into RC cars for a few years. It wasn't until I attended a RCX, or a radio-controlled expo, that I found out that combat robots existed outside of the TV show. I built my very first robot from a Team Think Tank VDD kit that Ted actually made. The kit allowed you to build to your own design, and in 2004 at RCX I placed third out of about 30 robots. Ted Shimoda himself was so impressed that he invited me to his bi-monthly events at his workspace. After doing very well at those events held at the workspace, I eventually started to sneak my way into helping build some of the larger robots. One of the hallmarks of Team Think Tank designs is always our composites. In high school I actually ended up taking composite courses at a community college. And as I learned more about composites, I realized the strengths of building with them in combat robots as you get more weight for your weapon, and ultimately your robots can be even more destructive. The other side of Team Think Tank is innovation. No matter what, we never really rebuild the same robot just to win. We always want to try a new technique or a new style in some way, so that way we can test ourselves and see what really works. When you start to scale up your winning designs, you realize that things change and weight profiles change and parts change, and you have to kind of adapt as robots get bigger. We eventually scaled our winning design up to VD6, our 220-pound heavyweight that competed at Battlebots and even beat Tombstone. In fact, none of our 4 victories were over 30 seconds. Unfortunately, at the very next event, Tombstone actually destroyed VD6, but to a builder, this is a blessing in disguise, as it means we get to rebuild it even better. In order to start where we left off of VD6, Ted Shimoda and I have decided to team up with Team Bad Kitty in our pursuit of a champion 250-pound robot. There is no more time to play around. We are completely serious, but we do have a little girl driving one of the multibots. Don't worry though, Katie Mason's going to show the world what a girl with a combat robot can actually do. We've gotten them up to speed on the basic design philosophies when going up to a larger robot, and they've been helping us design in 3D software exactly how we can build our next destructive robot, Bad Kitty. The design is comprised of a main 220-pound robot and either a 20-pound lifter bot or a devastating drone. Now, let's talk about our main weapon. This is our weapon system. This ran in VD6 and BattleBots in 2009 where it beat Tombstone. This spins vertically, has a 2-toothed design, 2-inch thick AR500 disc. This E-Tech gets applied about 60 volts in the new version. And being it's a 72 RPM per volt motor, that means this motor is spinning nominally about 4,200 RPM. After it gets belt reduced down to the weapon, you're seeing about 2,100 RPM. Now if you calculate tip speed, well, let's just say this thing's going fast enough. With our combined efforts, we have a design that is true to Team Think Tank, but we also know that robots tend to need an actual vent to be proven solid. This is why we have a steel subframe and a composite outer body. We know that not only will this design work, but it can be built in time for the event. Let's now meet the new team members of Team Think Tank.
My name is Martin Mason. I'm 43 years old. I have graduate degrees in physics and robotics. I'm the chair of engineering at Mount San Antonio College, and I also run the robotics team there.
My name is Tommy Thomas. I'm 26 years old. I work as a lab technician at Mount San Antonio College, and I work on the side selling robot kits for high schoolers.
My name is Katie Mason and I am 12 years old. I have been doing combat robots for 4 years, since I was 8. I wanted to get into combat robots because when I was younger, I would see my dad working upstairs on regular robots in the garage. He encouraged me to help him work on bigger, better robots with weapons.
I got into combat robots 4 years ago through a competition Mount Sac hosted at RCX. I built a robot, a vertical spinner, and competed and won the Rumble.
I've been working in robotics for nearly 20 years. My primary research interests have been in humanoid robotics and in human-robot interaction, specifically children working with robots. I got into combat robots 4 years ago when I realized my engineering students didn't have a lot of the fabrication skills required to be successful in their engineering careers.
So what are our responsibilities?
I'm going to drive Little Kitty, which is a cam-powered lifter, and its main motive is to get underneath the larger robots
To help fabricate the robot and to fix it when it breaks down. I'll be driving our Flybot. I'll be using FPV to go and find the enemy robot and rain down destruction.
My responsibilities for the team are to bring my background in electrical engineering and robotics to really help them step up their game. We're going to have some autonomous systems and monitoring systems on the robot. We're going to also make sure that all of our electrical motors, speed controllers, and everything else can handle the very high voltages and currents that we're going to be putting them through.
So how do people describe us?
Normally people like, oh, when I first met you, I was really scared of you. Like, I don't know, I thought you were going to kill me or something. And I don't know. I don't know why they say that.
Oh, you're that crazy professor guy, and I think I got that reputation because there's always smoke coming out of the garage and fire and all kinds of other things going on. And so I have this reputation of being, I guess, a little nutty. I'm not at all.
I think that other people think of me as like that weird kid that has a cat and talks about it a lot. And I think they tell me that I talk about robots too much and how I would like to make my cat a robot so that I wouldn't have to feed it. But, you know, they gotta learn.
Outside of combat robots, well, I do more combat robots. I run several events in Southern California, and I live stream them as well. In addition, I help with a 15-pound combat robot league in Southern California. It has about 20 area high schools, colleges, community colleges, and youth groups, and I also build kits for them.
You'd be a fool not to seriously consider us, let alone think that we don't have a chance at winning the big nut.
What do you say to people that think that girls can't do this?
They're wrong.